Now you may think, oh, mobile IP, that sounds simple, so where's the problem? Well, there are several things to do before you can use mobile IP. First of all, how do we know where we are? This is why the home agent and the foreign agent, they periodically send so-called advertisement messages into their physical networks. And with the help of the advertisement messages, the mobile node can detect if it is at home or in a foreign network. So if the mobile node is at home, standard case. If it's in a foreign network, the mobile node can read the key-off addresses from the foreign agent advertisement messages. So by comparing the network prefixes, the mobile node can check, oh, that's the same or it's a different network prefix compared to the network prefix I have in my IP address. The mobile node can register, so the mobile node grabs a key-off address and signals this key-off address to the home agent via the foreign agent. And then the home agent acknowledges via the foreign agent to the mobile node, everything fine, I noticed that you're now somewhere else. And these actions, they are secured by authentication. And after that, the home agent knows where the mobile node is and can advertise the IP address of the mobile node. That's the same as in fixed systems, so that's now the normal routing. So you can adjust entries and routers, and these entries are stable for a longer time because this is the kind of a more or less permanent IP address for the mobile node, no matter where the mobile node is. And all the packets someone sends to the mobile node, they're all sent to the home agent. And this is independent of the changes of the key-off address and of the foreign agent. So that sounds simple. Advertisement messages, registration, and then we know, okay, this is where the mobile node is. Just to give you some insight, again, as always, without discussing the details of all the fields, this is a part of an agent advertisement message. These are ICMP router advertisements, but they also contain key-off addresses. That's what the mobile node needs. So you see router addresses and you see key-off addresses. That's quite important. You will also learn what kind of encapsulation is used. So that's quite important because we have to create the tunnel. We see examples for this. And if it supports a so-called reverse tunneling. I will come back to this on some of the slides. So these are the advertisements. They are sent periodically on the subnet, and the mobile node will receive it and check the key-off address. Check the network prefix, detect, oh, I'm at home or not, and then, well, continues with the registration. Registration, very simple. The mobile node sends the request via the foreign agent to the home agent. Home agent checks, yes, this is really a device of mine, and answers, yes, that's one of my devices. Everything is fine. Maybe you noticed the problem. This is in case of we have the key-off address at the foreign agent. What does the foreign agent know? If mobile node and home agent are both evil, they can claim anything. The mobile node in the foreign network will say, yeah, I'm from this network, and the home agent will say, yes, sure, everything is fine. How can the foreign agent prove this? Now think, you being in a foreign network, company network with your mobile node, and you're from a different company, would a company allow this? There's also the registration if you have co-located key-off addresses, so you can directly register from the mobile node here at the home agent. Registration requests, they contain, as I explained, the key-off address. That means, hey, home agent, now this is the address where you can reach me. This is when you move to another city, you tell your parents, this is my temporary address. So if there's anything arriving for me, please forward everything to this key-off address. That's part of the registration request. Okay. So that's quite important. And again, some more fields, type of encapsulation, and if you want to receive broadcasts or not. Think of you traveling somewhere, you really want to receive all the broadcasts in your subnet. Maybe if you're at home at the university network, yes, but if you're traveling, maybe no. And then your home agent will answer and will tell you, hopefully, everything is fine. So registration accepted, that's great. Or maybe, no, I don't know you, something like this. Or maybe also the foreign agent will tell you, no, I will not register you. So that's the reply. So that's usually the simple part. So you're in a foreign network, you register your mobile node. The home agent now knows the care-of address, either co-located or at the foreign agent, and can now set up the tunnel. How is this done? Well, it's not complicated. That's always the same in the internet. To set up a tunnel, you take your original data with a header and the data, put it in a new packet, and you have a new IP header. So then you have an outer header and an inner header. And the outer header, in the simplest case, is again a full IP header. So that your packet now looks as follows. You have your outer header, and the outer header says, okay, this is a packet that goes from the home agent to the care-of address. That's stated here. And inside this packet you will see again, that's the original header. You see, originally that's from the correspondent node to the mobile node. So you see, this is the letter in a letter. Your parents, they place the care-of address at the receiver on the outside, the outer envelope, and their home address as the sender. So that's the idea. And the classical encapsulation is the IP in IP encapsulation. So that's quite common. So this is also used for encapsulating IPv6 and IPv4, multicast and unicast in the very early days of the internet. So this creates a tunnel, and this is the mandatory format in mobile IP from the very beginning. But as you see, you may copy some of the fields. So maybe here you copy things, you repeat some of these things, and there are some more efficient ways, minimal encapsulation, or there's a more generic format called GRE, generic routing encapsulation, just to make the picture complete. Here, this is a more updated, more powerful version of encapsulations. You can do many more things with this. So this just to show you, okay, a tunnel is created. You should know at least IP in IP encapsulation. GRE is used in many different places, so just to make it complete here. Okay, now everything is fine, isn't it? So we have the tunnel, we are registered, and now we can send packets from correspondent node to the mobile node. Everything is fine. Yes, but you remember the correspondent node sends the packet to the home agent, well, to you, but the home agent intercepts. Home agent has a tunnel to the care-of address, which can be your mobile node or the foreign agent, and then you send back. That's a triangular routing. Now this could create a real high latency. Think of you moving with your device to your friend in a complete different country. If you have your old IP address, all the packets from your friend, first they go to your home country and then back to the country where you are. So although you're in the same subnet, maybe sitting in the lab together, well, it takes quite long for the data to travel. High latency, network load. So why not learning the current location? So why not directly sending the data to the mobile node? So you could do this. So why not directly applying a kind of a tunnel? And this indeed can be done. I will show you how it works. So the home agent, after you send the first time a packet to the home agent, well, to your mobile node, but the home agent accepts, the home agent can tell you, like your parents, oh, thanks for the letter, but now the new address is this and that. And then please, from this point on, use the new address to your friend. So you can directly send to the mobile node. So the home agent informs the sender. But maybe you don't want your parents telling everybody where you live by now. So there might be some security problems. Think of mobile IP. If you do this kind of optimization, you simply ping a mobile node every 10 seconds or whatever, and you can track them. You can track the subnets because you will get an update as soon as the mobile node migrates into a new subnet. So, security issues. So that really is a problem. Think of it. Change of foreign agent. Well, if you optimize, you can help changing. I will show you this in an example. What you can do, how you can inform the old foreign agent about this migration to a new one and to avoid packet loss. Okay, how is it done? And maybe you remember this seamless handover in LTE, everything is IP based. Yes, we are close to that. This type of seamless handing over from one foreign agent to another one, well, from one eNode B to another one. That's exactly the situation we have here. So what happens? The correspondent node sends data to the mobile node, not knowing that the mobile node is not at home anymore. The home agent forwards the data to, maybe let's say the care address is now at a foreign agent, to a foreign agent, but also sends a so-called binding update to the correspondent node, telling this node, well, please update your bindings, the mobile node is now somewhere else, and this is acknowledged. Now the correspondent node knows, okay, the mobile node is not at home any longer. What else happens? The foreign agent forwards the data, as we learned, to the mobile node. Happy. For the next packet, the correspondent node can directly send its data to the foreign agent, which then forwards the packet to the mobile node. Happy. Now the mobile node changes the location. That means you attach to a different whatever wireless LAN hotspot belonging to a different subnet. We are talking here only about layer 3. There may be additional wireless LAN roaming or whatever. That's not important here. Here we're discussing layer 3 issues. Okay, layer 2, that's always added. So now we perform the registration here. The new foreign agent knows, okay, there's a new mobile node, and you also tell the new foreign agent, well, my old foreign agent was this one, and this means you send also an update to the old one, which is acknowledged. So now the old foreign agent knows where you are at the new foreign agent, but not the correspondent node. So the correspondent node, there might be still some data in flight, some packets, and they will reach the old foreign agent. And now, to make the handover lossless, remember LTE lossless handover, that was also one of the schemes there, you will forward this data from the old foreign agent to the new one, which forwards it to the mobile node. So no data is lost. But at the same time, the old foreign agent will send a warning to a correspondent node telling, I'm not responsible any longer for the mobile node. Not telling where the mobile node is by now, because maybe this could have changed yet to another foreign agent. The old foreign agent just tells, well, I'm not responsible any longer. Please ask the home agent. Not shown here is the registration that also goes to the home agent. So the home agent knows where you are. So again, you get an update, you ACK it, and then the next data is then directly forwarded to the new foreign agent, forwarding it to you. So that is the basic scheme of moving without any data loss from one foreign agent to another one. But remember, you know where someone is. We will see how this can be handled in, for example, cellular and mobile phone networks. So if the home agent also, for example, belongs to the operator's network, then you, as a correspondent node somewhere outside, will not notice where the mobile node is. It's just if you will get this update. So there are some tricks how you can hide this, because you don't want to have this kind of tracking of devices. So what else can be a problem? I told you that the way from the mobile node back to the correspondent node is very simple. Now what do we have quite often? Many companies have firewalls. And if a firewall detects that there's an outgoing packet with a topological incorrect address, and that's exactly what you do here. You as a mobile node send your data with topological incorrect address. The firewall will drop the packet. Because that means someone is sending with the incorrect address from your network. We will not allow this. So quite often routers / firewalls often only accept topological correct addresses. So what can you do? Instead of directly sending to the correspondent node, you can also encapsulate using the same tunnel, so create a bidirectional tunnel. You use the same tunnel for sending the data back to the home agent. Okay? And this means for the firewall, everything is topological correct. At least the outer addresses are correct. So that's a tunnel. Okay, and then their packets will reach the home agent. The home agent will decapsulate the packets and forward them normally into the internet. And that means, the packets also originate from the original home network. So, great. So we solve this issue with the firewalls using reverse tunneling. There are some more problems, maybe with TTLs, so time to live. If you stay in a tunnel, you do not count down the TTL, so maybe reverse tunneling also solves problems here. Tunnels and firewalls, that's a problem. So firewalls, they don't like tunnels because you can do whatever you want, more or less, inside the tunnel. So that's not really a good idea. Plus, instead of having this triangular routing, we now have this kind of going forward and going backward. So kind of 2 times triangular routing, or at least part of the triangle. So that's not very efficient, but at least the standard is backward compatible. And the agent advertisement, I indicated this already, they have this little bit that may say, okay, I want to have reverse tunneling. So what else do we have? There are some more problems. So security, I already mentioned. Authentication with a foreign agent. The foreign agent belongs to another organization. You move into a network from a different company, different institution. How can you authenticate yourself? Furthermore, there is no common protocol for key management, key distribution that is really widely accepted. We know PKIs, webs of trust, things like this. For email, we could use the TLS certificates, things like this. This could be used, but firewalls, that's always a problem, so we need special setups. You have to take care about the tunnels. And then if we have something like quality of service, think of specialized data streams for applications that need certain data rates, things like this. Differentiated services, for example, fields. The tunnel itself then also has to give this flow of special packets a special treatment. So that's always really a topic of research, of discussions, how to do this. Doesn't always work quite well. Some questions. How do you detect as a mobile node that you're not at home? How do you notice this? Then what is the difference of co-located care of address and a care of address at the foreign agent? how to optimize the triangular routing, because that might be really a performance problem. Why do we sometimes need reverse tunneling? What is this? And what are then the performance issues? And in general, which security issues come with mobile IP, and some of them are still not solved.